Hello, everyone. We're just going to get started here in a few moments and go through some housekeeping items before we get started with the presentation. All right. I think we're going to go ahead and get started now, Scott. So
Okay.
as I said before, hello everyone and welcome to another Cherwell acquired by Avanti technical deep dive. This one today is going to be about health checks and how to prioritize and align your configuration roadmap. My name is Tabitha Ishman and I'm the marketing manager here at Excalibur Data Systems, and wanted to jump on here and welcome you all to the webinar and then talk about a few logistics. The lines are muted and the webinar is being recorded. The recording will be sent via email to all participants on Monday. We'll answer questions at the end in a Q&A session, and you can feel free to ask questions at any time during the presentation just by typing them into the question window. A little bit about Excalibur is we are a leading edge consulting firm guiding organizations through their digital transformation journey. We work with strategic partners and leverage best of breed enterprise service management technologies. And I know we have a lot of great content to get to today. So to kick us off, I'd like to introduce Jeff Jones, Senior Solution Architect and Consultant here at Excalibur Data Systems. Welcome, Jeff.
Thank you. My name is Jeff Jones, as Tabitha mentioned there. I have been with the company here for about 16 years, been dealing with Cherwell since the partner program first opened back in 2009, so a little over 11 years at this point. And as she said, I'm one of the senior consultants here around the Cherwell product line. That's a little bit about me. Scott, do you want to talk about yourself a little bit?
Thanks, Jeff. Hey guys, I'm Scott Valor. I'm a Senior Solutions Architect and Consultant here at Excalibur as well, and I've been working with Cherwell for about 10 years or so. Started out as a customer, Cherwell admin, and did that for a number of years before I moved into the consulting role. So I've been working with Cherwell for a long time, and I've been around the block a few years in the IT infrastructure and management side of IT, pretty much anything infrastructure. So have seen a number of things that affect our customers. And I am going to go ahead and start talking about what today's webinar is going to be. So we're going to cover the health check. We're going to talk about these items here. When you want to do a health check, how you do it. Together, we're going to cover what that content in a health check looks like, in case some of you haven't actually run one yet in your system. And again, take some of your questions and see what we can do to answer those. A lot of the stuff that we're going to do is going to be on the screen, so we're not going to do a whole bunch of PowerPoint. So let's go ahead and pop over into the demo here, and we'll just go ahead and get my Cherwell admin brought up here. I'm just working in 10.2.1 today. And so we start talking about health checks. One of the first questions we always ask is, why would you want to run a health check? Let alone what one is, to start with. And so the health check is going to give you an overview of your system. It's going to let you see if there are indexes that need to be built, some performance issues. It's going to cover a whole lot of different aspects of your Cherwell implementation to help you see how you can improve the performance of your system. It's kind of the big picture of it. You're going to want to run a health check in the environment that you care about the statistics on. So if I run it in dev, I'm only going to get dev data. If I run it in prod, I'm going to get prod data. And you're going to want to run this, once a month, once every 2 months, as well as after you've implemented significant changes in your system, you're going to want to run it. One of the things, though, that will happen is when you make those changes, you're going to have to give the system several days to collect enough statistics to make it worthwhile running the health check to get enough feedback as to what has happened. So I usually wait anywhere between 3 to 5+ days after I've made changes, depending on how heavily it's being used, before I'll run a health check to see, what I need to tweak, if anything. You're going to need to have SA permissions to run the health check in your system. So if you don't have that, reach out to your system administrator to have those granted temporarily when you run the health check. If not, you'll have to coordinate that with them in some way. Be very careful when you run the health check, because it can take anywhere from a half an hour to a couple hours, depending on your system and how things are running. And it puts a fairly large load on the system to pull that. So you'd like to run these after hours, ideally. Best practice there. When we go through the health check that you're going to see, be aware that the order of the sections will vary. And it'll vary sometimes just between the run that you've done 2 weeks ago and the run that you do today. So just be aware those switch out. And you won't always see every section in every health check that you're going to do. And then one of the other things is make sure that you save your health check file, which because some of the statistics that you're going to gather are only valid between the last time that you ran the health check and the current health check that you run. Those statistics will be purged and it'll calculate new ones. So I would keep a history of that. Okay. I want to show you where you run the health check, as you haven't seen that before. So here within the admin tool, we're going to come over to the performance section and tell it we want to run the health check. When it comes up, everything is selected at first. And for your first run, definitely do that. However, if at some point you want to just do a quick health check because you're just trying to find, say, the save and refresh commands, you can individually select the modules that you want to have run within your health check and kick it off. You don't have to run everything. And then when that finishes running, you'll be able to save that out as an HTML file or other formats and be able to refer back to that as you're working through. So the version we're going to show you is that we had saved it as an HTML file. All right, so I want to hand this over to Jeff, and he is going to show us what a health check looks like that we ran in our system and start talking through some of the content.
All righty, thank you, Scott. All right, so what we have here is a health check that we ran a little while ago in a 10.2.1 system, our system actually. As you can see, this has been saved out as a HTML page, and I have this opened up in my favorite browser. You do want to open this in a modern browser because there are some features in here with some of the large fields where you can resize them in a modern browser that you can't do in IE11. So we're just going to go through this kind of section by section in the order that our particular health checks fit them out. As Scott mentioned, depending on when you run it, what sections take longer to run, the sections may reorder, and all sections may not always be available. Sections have been added to the health check over time, so depending upon your version of Cherwell, you may not even have all of these sections available depending on what's going on. But anyway, so let's just jump right in here. So each of the sections is kind of one of these blue boxes with the title bar on it. We'll just start at the top here. So the first section is kind of system information. This is basic information about the Cherwell environment that you're running against. When it was run, the version of Cherwell that you're on, who ran it, what type of connection. So this is a 3-tier connection, and what the connection name was that ran it. Those sorts of details. Just kind of diagnostic information about the health check. Sometimes the version information or the connection details can be helpful when you're troubleshooting things. The next section here is the business object unique attribute check. As you can see in our system, this area is blank. What this will show you though is any place where there's an attribute that is supposed to be unique in the system that is showing up multiple times. If you see something here, it's something that you need to deal with because it will affect the functioning of your Cherwell system, particularly around the scanning and publishing of blueprints. You'll start seeing errors about unique attributes being duplicated. So basically what you would see in here is you have one of these duplicated objects, attributes, you would see the attribute name and then the objects, all of the listed objects that attribute is on. Keeping in mind that Cherwell can have multiple views, so it has a default view and the portal view. These attributes can only be on the one object in one view, and they're usually in the default view. So if it gets into both views, you'll get the error. There are 4 different possible attributes that will show up here. Those are the customer business object, the default primary business object, the configuration item business object, and the journal business object. And I will jump over really quick to Cherwell and show you where these items are set at so you can know where to fix them should you ever run into it. So in a blueprint, those 4 attributes would be on one object. So if we look at the customer object, the group leader for the customer here, and we go into edit that group, and then we go up to our business object properties button. And finally, when that pops up, if we go to the advanced tab here and go into the general attributes, we'll see several attributes. This one here, this customer business object, is one of those unique attributes that should only ever be on one object in one view, and you'll start getting errors and seeing that show up in the health check should it ever end up in multiple places. So all you would have to do potentially is go into the other places where it's identified, delete it from there, republish your blueprint, and it should go away. If you have problems doing that, you'll probably need to contact support or your partner to help you figure out how to get that resolved. All right, let's go back over to the health check here. Our next section here is the plugin manager. So all this is telling us is the version of the .NET assembly that's being used to run the health check. And if you're running on a 3-tier system, it will tell you both the local version of the client that's on the client system that you're running and the remote version that's running on the server in case your client is different. It's not really useful for anything other than being able to know what version it is. Support may ask you about it if you're working with them on a health check issue. Okay. Our next section here, the check database section, gets us details about the database that Cherwell is running on. So this is going to include information about the name of the database, the name of the server that the database is on, what type of recovery model is set up, the number of packets sent and received, total reads and writes, basic SQL statistics that may or may not be useful. It can at least give you an idea of an overall level of traffic that is occurring and a number of errors that are occurring. This is one of those things that is cumulative from the last time the SQL server was restarted. So every time you restart your SQL server, these details will reset to 0 for the ones that are cumulative. So most of these through here, and it will start over at 0 every time. So just keep that in mind, that these are not persistent forever. Okay. Then our next section here is kind of one of the first ones in the health check that starts driving us towards figuring out some issues that might be going on in performance. So this is the worst queries by average read. So this is what SQL, and keep in mind that most of these come from the SQL server's perspective. These are the ones that SQL thinks are the ones that are causing the biggest performance issues in terms of, in this particular case, in the terms of the number of reads occurring against the objects to get to an answer. So what this gives us is kind of some details about how many times it was executed, what the average amount of time is it takes to run, how many times it has to read in order to return a result. And then it gives you over on the right, the final column here, it gives you the actual query with parameters, because it doesn't give you the actual details at RAM, but the parameters that were the parameter placeholders that the query was run against. So if you pick this query apart, you can find out the tables that were involved by looking at the from statements, what columns were used to constrain the query by looking at the where clauses. And then using that, And taking this information in combination with some data later in the report around missing indexes and then a couple others, you can kind of correlate, get to that point where you're correlating where the performance issues really are at, and what details you might need to be looking at in order to improve performance. So this is a query on a task, and it's looking at another table for the project ID, and then it's looking at some fields. So by looking at this and picking it apart, we can see, well, if we had an index on the project table that was covered these fields and an index on the task that covers these other fields like the billing type and the start date time, it might improve performance. So it's not a guarantee that it will improve performance, but it's a place where you can start looking to see those sorts of things. And in combination with some other details, you will get a better answer. Also keep in mind that just because something shows up here, and this is true of any section, just because something does show up here, doesn't necessarily mean that it's something you want to change or that it's actually bad, because it might be something that's expensive, but if you only run it once a month and it takes 5 minutes to run, well, that's expensive, but it's only being run once a month. Do you really want to spend 6 hours trying to track it down and fix it for 5 minutes a month? That's a question you have to answer, but it may not be something that's worth the time and money to resolve. Okay, so the next section is the same exact thing as the above section, except that this is breaking it down by the amount of CPU used rather than the amount of reads required to complete it. Same basic layout, how much time was spent, how many reads are required, what was the actual query. If you see things that kind of are in both of these lists, that is probably something that you want to pay extra attention to, because it's being expensive not only in terms of reads but query abutting CPU. It probably is something that really could use some focus and some attention to drill down into and figure out what those fixes are to improve those queries. You can, when you look at these queries, you might also be able to get an idea of what search it is that is causing that. Like looking at this one here in our previous section, that one I happen to know, based upon what it's doing, is from a weekly report that we run internally. And I could go look at the search that's related to that report, and then maybe reordering the limitations, the clauses in that search, or changing the way it's working from a related clause to a child object clause or something like that, might improve the performance. So there are some things you can look at that way as well. Okay, so the next section after those is the SQL wait statistics. So really, this is the top 20 reasons that SQL is spending time waiting for something. This is not a bad thing. SQL is going to spend most of its time waiting because even though you may think, oh, well, we got people using the system all the time, really in terms of computer time, it's really not doing anything most of the time. So you will see these values in here will always be here. They will change over time. Different ones will show up. These times again are cumulative. They're from the last time that the server was restarted. So this is the total wait time for this particular wait reason. That since the last time that we restarted our server. Really, there are a couple that you would need to be concerned with. If you start seeing anything in this list about blocked I/O, that generally means that you're starting to see some sort of resource contention, either on your disk drives or in your memory or on your network. And you should have your DBA look into those, because those are the ones that are going to start causing significant hiccups in latency and performance in your system, generally speaking. Right? So the next section here is the table size statistics. So this is basically a list of the top 20 tables in the Cherwell system that you run the health check against, purely by the number of rows in the table. So this doesn't look at the actual size of the table, how much space it takes up on the disk. This is based purely on the number of rows that are returned, that are in that object. So as you can see, in ours, journal is the big one. It's got 130,000 records. Our system is small in comparison. You will commonly see the journal, the attachment table, and the email tables will be usually your big tables that you will likely to see at the top. And in a heavily used system that's been around for a couple of years, these values can get into the millions of records. This information is useful for a few things. One, the more rows there are in a table, the better, when you add a good index to it, the better performance increase you're going to get. Alternatively, the bigger the table, if you add a bad index to it, index that doesn't do anything, it's not useful for any purposes, the bigger performance hit you're going to get, because every time you add a record to a system, it takes a little bit of time to update the index and add that to it. And the bigger the table is, the longer that takes, because it has to rebalance trees that it uses to do the searching efficiently. So the bigger tables are definitely, something you should pay your attention to when you're looking at indexes that you might want to add. So on ours, the journal and the tasks here are pretty big. So we would probably want to, pay attention to anything that tells us that we need indexes around those. And we saw some of those in the section above. The task was the very first one, right? The other thing that this can tell us is if you have a plan to archive your data, this can tell you where you can get benefit from archiving your data based upon the number of rows and the size of those rows, where you can get the most benefit from, like, archiving old journals out and decreasing the number of rows and the size of your database. So it can be useful for that. I know right now Cherwell does not have a built-in archiving method. There are things you can do on your own, but there is a archive functionality coming in a release within the next year or so from their roadmap. Right. So the next section here is the index usage statistics. There are actually two subtables in here. The first one is the top 10 index usages by user updates. So this is the indexes that would have applied to an update of a record or the creation of a record from a user's perspective. The second one is the same sort of index, a top 10, but this is by user seek. So how many times the user is actually going out and reading data. So one is for writes, one is for reads, more or less, if you look at it that way. So a couple of things that you want to pay attention to in this section. The first one is up in the top here, the user updates. If you see items here which have a low number of user seeks, but a high number of sorry, backwards. It has a high number of user updates, but a low number of user seeks. Make sure I got that in the right order. We're updating things here. So if we're using it for a high number of updates, but a low number of seeks, that means that this index isn't very useful for us for actually doing the searches, for doing the retrieval of data. And in those cases, in that situation where the numbers on this side are low and this number over here is high, that is an index that we could consider for removal because it's not actually helping us performance-wise. So that's the way that you can look at this one here is low seeks, high updates means that it's a possibly incorrect index that you don't need. And then in the bottom section here, if we have indexes that have a high scan, that can indicate a place where we need an additional index that doesn't currently exist. Not necessarily because these are still indexes, but the scans means that in addition to using the index, it also had to scan a certain number of rows of data. So if you have a high scan, it could indicate that the index isn't quite covering your needs and you might need another index there. All right. So I'm going to pass this back to Scott to talk about some of the next sections here for a little bit. And I will join back with you after he is done. Go ahead, Scott.
All right, thanks, Jeff. So we're going to talk about the mismatched Def IDs section. Usually there's not a lot of stuff here, but if it does show up, then that lets you know that a definition stored in the database, has a definition ID stored in it that doesn't match the ID of the entry in the table. And that's something that has to be fixed. When you're running the health check live before you've saved it, you can click the repair button, which is here at the right, just to the right of all the data here at the top of the mismatched area. Or if Jeff can pop up the admin tool real quick, we'll show you where you run that. So you'll just pop over to the database section and system maintenance. And when that pops up, one of the, and this is a new feature, this was not in some of the older versions, you'll find fix mismatched def IDs. When you run this, it usually will take 30 seconds to a minute or so. It's a really fast thing to do. If you are upgrading from an older version prior to 10 and you get into any of the 10 versions, it's always a really good idea to go ahead and just run that anyway, just to make sure things get cleaned up one time, no big deal. But if you do see stuff here in this section, just go ahead and do the repair and that'll clean that up. The next section though is the runtime performance warnings. And this is kind of an interesting section. This one is specifically only shows you warnings since the last time that you ran the health check. So every time you run this, you're going to see different stuff here. And it's giving you the top 20 by category. So like in our system, you're seeing these first 20 are on reports that we have. And these are all because we're using rich text fields in the reports. So when you look at these, it's basically just telling you that it can't handle the indexes on these. No big deal. These will clear out, and the next time we run it, we'll see some different stuff. And if Jeff goes a little further, we've got another section on relationships. And so here it's talking about some of our relationships, and it's saying, you know, maybe we should load keys only, or we should add some additional constraints to minimize the number of records that have to be evaluated as part of that relationship. And these are some good tips here to look at. You don't necessarily have to action on these because sometimes when it says keys only, you may very intentionally be needing to load the entire table. Just be intentional when you take this advice and you take and make changes in your system. But it gives you some really good feedback here to definitely look at and go, oh yeah, that really does make sense. Let me run with that. The next section that we're going to run to is the save and refresh. So this is a new feature that Cherwell has added. A few versions back, Cherwell changed how the execute command runs. So when you say I want to execute a command and I want to save or I wish to refresh, those are now really compute intensive commands versus like say doing an update business object where you reload it, which is a refresh, or you choose to save. So Cherwell was trying to do two things. One, call out where you have a lot of the save commands, as well as many people were saving multiple times in their one steps when it wasn't really necessary. You could save once you finish doing all the changes in a record. So they wanted to highlight where you have multiple saves or multiple refreshes in a one step to help you chase down performance bottlenecks, that you could look at each one of these and go, oh, yeah, I really can tweak that one. I don't need to save after I've updated 4 fields in 4 separate blocks in the one step. I can do it on the last one. So just use this as some guidance to help you try to find some of those. The next section is the foreign key configuration. And so when you have foreign keys in your system that are possibly not configured the same between, say, the default view and the portal view, Cherwell's going to let you know that here, as well as if you have areas in here where it says, okay, we have said we're using foreign keys, but I haven't enforced validation. And if you're not enforcing validation, the foreign keys don't necessarily work properly. So because we have an older system that globalization's been added to, we're getting a lot of foreign key errors. We're not using the foreign keys, so for us, that's not a big deal, but something that you may want to look at if you're having some issues with your data integrity. The next is the one-to-many relationships and expressions. And what Cherwell is trying to point out here is a particular relationship where you're using an expression to define how you limit the data in the relationship. And these can be compute intensive because it has when it does the select, it tries to do a calculation versus passing actual data. And so it's not always able to use the indexes. So it has to look at all the records. So it's pointing those out for you so that you could go back and look at these and go, could I turn those into a different form of a relationship, the constraints around the relationship, so that it's more efficient. And so they're just trying to point those out for you. The next section is a really interesting one. This really helps with performance. It's the cacheable objects. First, don't make every one of these cacheable. Be very intentional here. But Cherwell is saying, here are some business objects that we're seeing used quite frequently that if we were to cache them, could significantly improve the performance of your system when you're driving a drop-down table or something. So, maybe we want to look at, I don't know, like the quick journal. So the templates we have for our journals, for when we're doing journal notes, maybe, those hardly ever change. Maybe we would turn those into a cacheable piece of data so that Cherwell would cache them. Now, be very careful when you're caching stuff, because if you have large text fields, more than about 200 to 300 characters, and you don't check that you want to cache that large field when you turn on the caching, then that data is not going to come through. So we'll show you where you would do that on one of, excuse me. So when you come in here to the advanced section, we want to set whether or not it's cacheable. Here in the middle, we would say it's cacheable, and then the checkbox to the right is the large text field. So if you have a field that's got more than about 200 to 300 characters in it, and you don't turn that on, when it caches it, it won't cache those, and so you'll just get blank data in those large text fields. So just kind of be aware, pay attention. That doesn't come on automatically. You have to check that when you turn it on to be cacheable. So just, make sure that you pay attention to that. The next thing that we're going to look at in the health check is going to be the missing native REST API clients. If you see something here, you have a problem and you should call support or your partner. Support's going to help walk you through that. Specifically, what this is referring to is Cherwell builds some behind the scenes web interfaces for like the API connection for authentication and stuff, and some of the other pieces that it does. If those are messed up, as far as it can determine, they're going to be listed here. And so you know that you have an issue with that configuration of the data. All right, I'm going to hand it back to Jeff so he can talk about some of the missing index rules.
All righty, thank you, Scott. Okay, so our next section here is the missing index rules, another very useful section of the table. So what this section gives us is a couple of things. The first piece of data that we get in here is the top 20 indexes that SQL thinks need to be created to improve the performance of your system. It does this calculation based upon this total cost, which is a combination of the number of times that that query is run, the average impact it assumes it will have on a user, the number of seeks required to complete the search. Those sorts of details are combined together to get a cost that it uses to generate this. Cherwell has a rule of thumb internally for this that they will almost always create an index on something if the cost is over 5 million. But that doesn't necessarily mean that that is a hard and fast rule that you always want to create those indexes, or that something less than that shouldn't be created. It depends on your individual circumstances, because it may be less cost, but even if it's a less costly item, if it's being run more frequently, the cumulative impact may be a bigger deal. The appearance of performance may be more important than the actual performance in some places. All right. So this is one of those sections in this report which is directly actionable within Cherwell. However, this gives you every piece of information that you need to turn this into an index in a blueprint directly. It gives you the table name, the fields that are involved in the index, so the equality and the inequality usage fields here combined, would be put together, equality first, inequality second, and used to create that index for the table. And then the final section over here is this include columns. This is additional data that SQL thinks you should add into your index. It's not used as part of the actual index for improving the performance of the search. What it is a search record, an index record is just another record in the database. It's just stored differently. The included columns are also brought over into that record and added to it. And the intent is that if you have a use case where you frequently are doing a search based upon these fields, but you also are looking at this additional piece of data, it can return that search record at one time with the additional data and not actually have to take what it finds in the index and also go out and do a secondary read on the database table to return that row and get the data for you. Because of that, you will find many times that some of these records are identical other than the include columns. Like for us in this particular instance, this row here, row 5, and this row here, row 7, the fields involved that are actually being used in the indexing are the same. And the difference is in the include columns, the owned by and task duration hours versus just the task duration hours. So when we are using this at this table to figure out what we want to create in Cherwell, we would take these two rows, since the fields involved in the equality and inequality are the same, we can combine these two rows together and create a single index. And by doing so, we've basically realized that this total cost is wrong. This is actually closer to, 150 million, not 74 here and 62 here. You can combine them together to get a total cost. So that actually becomes a more important query than it looks like on the screen. The way that you action this is actually pretty straightforward. If you get the list of fields, the table, and the columns, you would just go into your object in Cherwell, create yourself a blueprint. In Cherwell, we would find the task object, and as Scott said, we started an older version, so our task object is actually task as opposed to something else. We will edit this business object and go to the properties for it. And then on this properties dialog box, we have the database options. And this is where we set up all of the indexes for this object. So we would just say add a new index, give it a name. So we'll call this something like task billing details or something like that. And then we add those fields that it was telling us that need to be index columns. So all of ours happen to be inequality options, but that's fine. So we needed the billing type. We'll add that one. We needed the start date and time. Add that one. We needed the duration, the task duration field. Add that one. And we needed the time is not billable field. It's down here somewhere. Right, so those are the 4 fields in our report that were included as the inequality fields. Then we had those 2 additional included fields. So for the included fields, we do the same thing. We would add them. So in this case, it's the owned by field, but we would also check the box here to say include. This says include this as part of the data, but it's not included as part of the index for searching reasons. And then the other one was the task duration in hours. So now we have our index created. We would just click OK here, save the blueprint and publish it. It would then, as part of that publish, it would rebuild the index on this table. And since, in this case, task, or if you were doing journal or something that can be quite large, that rebuild process can take a while. So you might want to, limit some of these things for creating new indexes and stuff to weekends or after hours or downtimes, just in case, because it doesn't give you a performance issue. Let's jump back over to our report here. So that's how you use this. And like I said, this is one of the more important sections because this is directly actionable. And these SQL is generally pretty good about knowing that it needs an index for something. And that index, as we were just looking at there, I don't know if you caught it or not, but that directly relates back to that worst query that we were looking at, because this actually is the same query that was related to for a report that we run every week to see how our consultants are doing and their time, the entry that they're supposed to be doing. Right. The same section of the report, the missing index rules, has this section here, which is index structure. This is just a list of every index in your Cherwell system. You will see occasionally, more than occasionally, you will see the same table and index name listed multiple times. Find one here, right here. Here's a good example. So incident and all of these incident types, this is all one index, but all of these fields that are listed on the right-hand side are involved in this index. So when you're looking at this, keep in mind that there's one field per row, and you need to look at the combination of rows to figure out what the index actually is. So this tells you that which fields are included. So these are included fields that are not actually part of the index, but they're part of the included data, what order they're in based upon these last two columns. Okay. And then there are two more sections in here once we get past all of our indexes. These are the top 10 index usages by seeks and by updates. These are identical to the section, one of the sections up above, where it had the index statistics. The tables may be different by a number or two because they're run at slightly different times. One's run at 1 second after the hour and the other one's run at 2, so the numbers may be just a smidge different, but they are basically the identical things as the ones we looked at before, where the updates, if we have large numbers here but low numbers here, maybe that's something that we need to remove that we talked about earlier. So that's just a duplicate that is here for reference purposes. Okay, getting close to the end here. The next section is the network health check section. This is a diagnostic tool for network, not necessarily Cherwell or SQL Server issues, but network latency and performance issues. The data that you see here is only seen from health check to health check. So every time you run a health check, this data will change. But basically what this is when you are running the rich client as a technician, if you have the appropriate permission set, there will be an option on the tools menu to run a network health check. And when you run that, it is going to talk to the Cherwell server. Whether you're using a 3-tier connection, I'll talk to the application server. If you're running a 2-tier connection, it's going to be talking directly to the database. And it is going to transfer a series of different size data files to the server. So it's going to copy a 1 meg data file, a 10 meg data file, and a 100 meg data file. And it's going to copy each of those a number of times, and it's going to get statistics about how long it takes to do each cycle through that and give you some averages. So you can kind of see here what that looks like. 1 meg data file, 10 times, the minimum, the maximum, the average. This is then something that you could take to your infrastructure team or your network admin team to say, these are the results we're getting. We're seeing a latency issue when the files get above a certain size, or from these particular clients in this network segment, we're seeing a latency issue that we need to have looked at. This is not something that is available by default. If you want to turn this on to run it for people, this is actually done in the admin tool through the user security. It's actually on the user records. This is done per user, not per security group, but per individual user. You would enable this. So in the user record here, there is an option down in the account details down here for allow diagnostics. If you enable this and save the record, then the next time they load up the rich client, they would then see that option on the tools menu to run a health check, and that's where that comes from. It does take a while to run. I think the last time I ran it, it took about 5 minutes on our internal network here to run the full scan. So, all right, and our next section down here is the section for check canonical compliance. This is related to a relatively new API method that Cherwell has added to the system. They've added what they call the canonical APIs, which are more of a traditional style REST APIs, where it is the name of the business object and the operation you want to perform, and a few other details, rather than the API the way they have it built, where you need to call a say business object, and part of what you pass it in as data is the object you want to update and the ID and the fields. It's a more traditional way, an easier way of looking at it. What this will tell you is if it finds any issues with the definition of those canonical APIs. So it's going to tell you things about whether or not it finds a definition that has a duplicate field, that you have two definitions for the same field, or a required field that doesn't have a definition in the canonical API. Or if the rec ID field is not there, because the rec ID is necessary even though it's not necessarily required. It's going to give you a list of what it finds so that you can go fix it. That being said, Cherwell's recommendation on the canonical API is that you do not attempt to create your own or modify the canonical APIs. They recommend that you use the definitions that they provide, and they provide maps for various definitions that you can import and apply to your system. But their recommendation is, because they're complicated to set up and problematic to set up, is that you use their definitions. And if you need another definitions, to work with support or your partner to try to figure those out. But that is the canonical compliance section. Next section here, the penultimate section, is the check business objects for consistency. So what this is going to do is it's going to do a scan through your definitions, and it's going to try to find any business objects that it thinks are inconsistent in their configuration. Generally, this is going to mean that there are duplicate fields in the table. There's two fields with the same name, which is not allowed, but somehow they got put in there, which happens from time to time when blueprints misapply or definitions are done by different people in the wrong order. But it's going to show you things like that, where there's something wrong with the table. There's a duplicate field, or a field is missing a required attribute, or something like that. Typically, these you may be able to fix on your own. So if it's like a duplicate field, you can open and you can open up that business object and delete one of the fields and republish it, and that may fix it. In some cases, however, it may be something that needs to be fixed at the database level rather than through a blueprint. So you may need to get your DBAs or Cherwell support involved, depending on whether you're hosted or not. And then the last section here is the out-of-date index statistics. So this is another one of those things that is kind of from the last time that the SQL Server restarted, the statistics are restarted. But the what this tells us is what indexes that you have built that SQL thinks need to be rebuilt, is really all it tells us. So when you see something here, really what you need to do is go run the command in SQL that rebuilds the index statistics, and your DBA can do that for you. It is recommended that your DBA, if you're on-prem, set up a nightly or weekly job that runs the normal SQL maintenance. That includes things like rebuilding statistics, redoing indexes, cleaning up old usage data, stuff like that, that you can run, that they can set up to run as a scheduled job in SQL every night or every week or every month, however frequently it needs to be run in your environment. If you're hosted, that's already set up for you. It runs, Cherwell generally has it set up to run nightly. And so you guys should only see in here things, if you happen to run this report right before, shortly before that runs, you may see something in here, not very likely even in that case. But again, the index statistics, your DBA should set up that rule. But like Scott was mentioning, with actually running the health check, that can actually be a performance hit. So you want to make sure that you're not running it in the middle of the day, and that it's run during a lower usage time, right? So, I mean, that covers all of the various sections that are currently available in a health check on the latest versions of the system. So I am going to pass this back over to Scott to wrap up this part, and then we'll go into the question and answers. Go ahead, Scott.
Excellent, thanks, Jeff, appreciate it. So on your screen, I am showing the resource link that takes you to the help page that helps you deep dive interpret everything that we covered on the health check. May have some additional answers to some of your other questions down the road, just kind of as a secondary resource for you. And to finish what Jeff said there on the statistics rebuild on your index rebuilds, one of the general recommendations is if your fragmentation in your indexes is less than 30%, just do a reorg, and if it's more than about 30%, go ahead and do a rebuild. I'm just throwing that in here because every once in a while your DBA will ask you, well, what's the threshold? How should we handle that? So there's just a good starting recommendation as you're trying to figure out where to set some of those thresholds as you're going forward. And then go ahead and pop over to the last slide here. So if there are any questions, go ahead and throw those out. We'll be happy to answer anything that you'd like to
Scott,
know.
there's one question here from Teresa. That does running the health check have any impact on production? Should it be run after hours?
Yeah, definitely 100%. So you're going to find, as Jeff mentioned, that it is going to be querying the entire database as well as the system portion. So it's going to impact your Cherwell system, and it may have a slight impact on any other databases that are running if it's a shared database server. So be cognizant that you want to run that after hours, and if you have evening stuff that's running on that, you might want to end up running it on the weekend then. But pay attention to the other loads that may also be on that same database server. Does anybody else have any other questions?
And in the meantime, if we have any other additional questions, if not, we'll close out with some final comments. But in the meantime, we'd like to invite all of you to our Quest for Collaboration. And this is a weekly meeting that we saw a need for in 2020. So if you've attended a Cherwell user group before, it is very similar to that as in there's no sales information included. We bring together our Cherwell customers, friends, acquaintances for an hour once a week to discuss problems and challenges as a group, and then we work together to share knowledge and solve issues. So if you can sign up and join us when you can on Wednesdays at 3 p.m. Eastern, and the link is right here on the slide. But if you head over to our website, it is under the resources tab.
Yeah, and that is a really great thing to experience. We get a lot of great conversations happening, and if you're not quite sure whether or not it's for you, just show up, be a wallflower. Not a big deal. Just hang out, see if it's something that you would find valuable, and connect with some of the other admins across companies that we interact with as well.
All right, so we didn't have any other additional questions come in. So is there any closing comments, Jeff or Scott, that you'd like to do before we close this out?
Just wanted to thank everybody for taking the time to attend the webinar, and hopefully you found something of value in it.
Yes, thanks everybody. I appreciate your attention.
Absolutely. We will see you all on the next Cherwell Technical Deep Dive. Thank you.
Have an awesome day.
Have a good day. Bye.